to do that. We work, 99 hours on the research, but we don't spend even an hour, sharing that in a easily consumable form, right? We are writing papers, but that's difficult to consume for a general audience. So we had a series of articles, thanks to Summit, Mike Coraluzzi, Pojan, and the team to really work with the COE partners, and all COE partners are welcome to do this, right? In fact, you should be doing this. We'll help you with that. It's very painless. And so this is Ziran's article on using LLMs and VLMs for personalizing autonomy, all built on top of Autoware, and really coming up with very new and exciting things. So in some way, it is helping the autonomous driving functionality itself, but in other ways, it is actually like a really great use case for LLMs and VLMs, and these are some demos. I have seen these, and they're really, really interesting of, how the vehicle's, behavioral planner is actually now exposed and expressed and understandable to the driver like that, right? So it's no longer like some black box that is there. I'm just switching the tab. I hope you can see now Hormoz's article on scalable tire dynamics modeling and learning for control over here. And so he's obviously control guy, so he goes into the math directly. But I think the whole point here is to show that, people are actually doing research and we are testing out these systems with Autoware. And then there is the UC Irvine team over here, Josh Garcia, Alfred Chen, and their awesome PhD students. I attended this workshop with them on the Cadre in the before the summer in UC Irvine. It was really well organized and a lot of really good discussions on, what are ways to find bugs, what are ways to automatically fix bugs, and they have some really very good top quality research. And the research has toolkits, and they work not just with Autoware but with Apollo and OpenPilot. And so this is a great way to, oh, I guess here's a picture. I did not see this before. And so this is a great way for, actually finding the bugs and making Autoware itself better. So again, here they are improving Autoware and the autonomous driving capability, but they are using it, since it is open source, to further their research. And both Josh Garcia and Alfred Chen got their career awards, NSF career awards, in part based on the work with this. And this is a further NSF grant that organized this workshop. So that's the other point I wanted to make, is that, working with the Autoware COE is actually, very beneficial to the academic careers also, because as a team, we can sort of work with the much more challenging financial conditions that are there for funding. But as a team, that gives us much more power and much more flexibility. And then, of course, there are, Professor Venkat Krovi from Clemson, his two awesome students, Chinmay and Tanmay. They ran the, sim racing league multiple times, and, sometimes with 60, 70 plus teams, but without, I think to me, what was amazing, without any hitches. There was no software bugs, no software crashes. Everything was so smooth, which, for a, university organized effort, it was really amazing. This is not some big company that is running this, but they have developed a really good, digital twin environment that is very versatile, not just for racing, but, really going for off-roading, for really looking at multiple, driving scenarios. It's a very flexible and useful piece of software called Auto Drive, and that incorporates Autoware as part of it. And racing is only one kind of personality of this Auto Drive. It is much more versatile. And once again, this is a really good example of how it is improving Autoware and allowing the community to participate, make Autoware much more accessible, but it is also giving them a chance as an open source environment and real systems to do their research. And so I think that's this really nice two-way, you know, we have found a very good way to benefit academics. So that's the just I just wanted to highlight four articles. So please take. I'll put these links in the chat. Ziran Wang and Yupeng's article on LLMs for autonomous driving, learning-based control with incorporating tire dynamics with Hormoz Marzbani's article, automatic software testing by Josh Garcia and Alfred Chen and their team are from UC Irvine. And then finally, the last one was Auto Drive from Clemson University's team. Uh, so given that, I'll pass the baton on to Pojan, who will give a overview of what Autoware's efforts are towards off-road autonomy and what kind of environments it sees with where's the future of off-road autonomy, because classically Autoware is focused just on, like say, a robo-taxi environment. Then it expanded to like, passenger-owned vehicles, then to low-speed autonomy, and then to racing with Johannes and a lot of the rest of the team here. And and now this off-road is, so in some sense, I'll just provide some warm-up to what Pojan, you can go ahead and share any slide you want to share.
Okay, so
Yeah, but I'll just give a brief intro. In some sense, yeah, off-road is providing like an ODD, another ODD, and there are, use cases. But in the other way, I see it from the research side, off-roading basically forces you to largely abandon this kind of modular, rule-based, explicit perception planning control pipeline to a much more agile, learning-based pipeline. And because the environment is now much more complex, and the environment is not a smooth clean surface with rules to drive along. And so you have to couple perception to planning to control, and the controller is now part of this, right? Before, the controller could just be an MPC and you would roll with that MPC. But here, as the terrain changes, as the terrain is evolving, the controller also has to be part of the loop. But that's just the perspective from the learning-based controller. Similarly, perception has a lot of problems. Similarly, planning, that you're not always going to have this path over here. You have to have contingency paths. You have to figure out how to navigate what is, people talk about traversability, but here we want to go even beyond that. Uh, and so if you haven't ever driven on that terrain, how can you even estimate what traversability would be? And so that basically requires you to depend on a lot of learning and eventually foundation models for this. Largely, the efforts in off-roading that we see with the DARPA Racer and the companies that have spun out are largely going in the defense direction. Autoware as a foundation does not, invest or focus on defense per se. So we would be focusing on, all the other use cases. So there is an application of, you know, and that's what Pojan will talk about. And then there is like, okay, now we need to build the guts of the system, but it's very different from Autoware, even the end-to-end Autoware that is there so far. So let me hand it over to Pojan. Then please ask questions and also see how you can get involved. It's a very exciting area. Many of us are already working on it. Johannes, Venkat, Christoph. So it's a very exciting area, and I think this can allow us to work together further. And yeah, William also. Yes, I see him there. Go ahead, Bojan.
Rahul, can you please let
Oh,
me
yes.
share my
Sorry,
screen? So
sorry. Yeah, I forgot the Zoom requires all these permissions. Go ahead.
hey, give me a sec. Okay, so can you guys see my screen?
Yeah.
Okay, so actually today I have like two topics to cover. The first one is the Autoware roadmap task force. So this is like a new initiative within Autoware that started earlier this year. And then on the second half of the presentation, I'll go over like what are the plans for Autoware's off-road working groups. So first, what is the Autoware roadmap task force? So earlier this year, Autoware came up with a list of objectives that we want to achieve in 1 year. We started this Autoware roadmap task force. So it is like a bi-weekly meeting for all the work group leaders. So we got together and then we structured the working groups, and then we came out with a detailed execution plan so that we can achieve the goals and objectives that the Autoware wants. So what are the objectives? So first, we want to incorporate like cutting edge technologies using AI first approach. So we want to transform Autoware from AV 1.0 to AV 2.0. So we want to use the cutting edge technology, like using the end-to-end approach for Autoware. The second objective is that we want to make like Autoware production ready, so it can be easily commercialized by the Autoware members. And then the third goal is that we want to increase the number of deployments. So we want to see the mileage start to like stack up that is running Autoware software. So we have restructured the Autoware working groups. So this is currently there are 9 working groups. There's actually one pending. There's a trucking working group that is still waiting to be approved. But yeah, currently we have 9. So for the core AV functionality developments, we have low speed autonomy, privately owned vehicle autonomy, and also off-road autonomy. So I'm currently leading the off-road working group. For enabling technologies, we have simulation software. For production and validation, we have safety assurance, ODD, OpenAD kits, and reference design. And then I'm going to briefly go over each of these working group and what are their goals in the coming year. So first, for low speed autonomy, so they are currently working on TRL6 autonomous driving stacks. So TRL stands for Technology Readiness Level. So for a TRL6, that means it is at a level that is like demo ready. So they want to build these software driving stacks that is on top of Autoware Core and also using the personally owned vehicle AI stacks to enable like low speed autonomies. And they are working on use cases in warehouse, cargo, or logistic vehicles. They also collaborate with Autoware Taiwan to deploy their software on a real vehicle in Taiwan. And all of the goals are divided into like 4 phases from P1 to P4. So each phase is 3 months. So this will cover from P1 to P4 will cover the entire year. So for phase 1, they are working on the definitions of the ODD, what are the requirements for sensing, perception, and autonomy, and what are the cost constraints. For phase 2, they want to begin the developments of the low speed vehicle autonomy stacks. For phase 3, they want to complete the first version of the full low speed autonomy stack. And for phase 4, they want to integrate with a real world vehicle. Okay. Next, I'm going to talk about off-road. Yeah, so for off-road, we want to enable off-road autonomy using end-to-end approach. And currently, for the use cases of off-road, we divide that into 2 main categories, the terrestrial vehicles. So this will cover use cases such as off-road racing, as well as like mining vehicle. The second category is like this for space exploration. So this covers like the Mars rover or the lunar terrain vehicles. Um, and for phase 1, we did a simulator evaluation. We want to find the best simulator for off-road autonomy. We also did dataset curation for image-based terrestrial perception. For P2, we implement like the Mars and also lunar simulation environment, we also began training the models for terrestrial perception. For P3, we want to complete the simulation for Mars and lunar environments, and also complete the terrestrial perception stacks. And for P4, we want to complete the first implementation of like the Mars navigation autonomy stack, and also test the terrestrial perception stack in Carla. So currently we are at P2. And next, the privately owned vehicle working group. So currently they are working on a foundational model um, for that focus on like highway driving, and also for like automotive OEMs and tier one supplier. And their work is like using only vision, so no LiDAR. So for phase one, they want to complete like a vision pipeline and begin the ROS node integration. For P2, they want to complete the ROS node integration, and also complete the autonomous pipeline and integration with Carla. For P3, they want to complete the full autonomous driving stacks, and also integrate with the latest Carla 0.10.0. Uh, and for P4, they want to refine their driving stacks from the 0.09 version. Um, okay, next, the simulation working group. So for simulations, they work on like simulation scenarios creation for the low-speed autonomy, privately owned vehicle, and off-road autonomy. So they are building new simulation environments and also assets for all these working groups. And they're also doing the integration of Autoware with Carla Simulator. So in phase one, they are uh, working on Autoware integration with Carla. They are also porting some of the new features, functionalities from Alsim Lab into the original Alsim. For phase two and phase three, they are helping the privately owned vehicle, off-road, and low-speed vehicle to develop sim environments and integrate vehicle models. For phase four, they propose to participate in the Open Drive Lab challenge. Okay, the software working groups. So software working group, they are in charge of like code maintenance and also building new APIs. They also work on the general software issues within Autoware. For P1, they want to finish porting the package to Autoware core. For P2, they want to fix the code issues related to ODD scenario failure case. For P3 and P4, they are focusing on end-to-end fusion with with current Autoware in perception and planning. Okay, for the next OpenAD Kit working group. So OpenAD Kit, they work on Docker containerization of Autoware, and they are working to support the low-speed autonomy and privately owned vehicle autonomy stacks. So for P1s, they want to do the containerization on Autoware Core and Universe, and also the documentation. For phase two, they want to integrate it on a real vehicle and also complete the documentation. On phase three, they want to add support for low-speed autonomy and privately owned vehicle use cases. For P4, they are working on like runtime orchestration, OTA support, and Auto SD Bluetooth. Okay, next, reference design. So reference design, they build like reference hardware architectures that runs Autoware, and they want to enable like turnkey developments for like OpenAD kit based low speed autonomy, off-road, and privately owned vehicle autonomy stacks. Yeah, and for P1, they are doing like reference design for low speed vehicle. For P2, they're doing reference design for also low speed vehicle but GPS denied environment. and also reference design for privately owned vehicle. For P3, they are working on low-speed vehicle demo at CES. And then for P4, they are doing reference design for off-road autonomy. Okay, next is the ODD working group. So ODD, they define the conditions that the vehicle can operate like safely. Um, so uh, so for the ODD working group, they have this like a complete testing and verification tagline, pipeline in Autoware. So they create a lot of scenarios to test the reliability of the software. And then they are also working to support the testing for a low-speed autonomy, probably on vehicle, and also off-road. And they are also trying to add support for scenario simulation without a map, and also with the standard OpenStreetMap 2D map, Linear 2 map, and OpenDrive map. So for phase one, they are running existing scenarios in scenario simulator and begin the initial creation of scenario in the standard description language. For P2, they are completing the base scenarios in the standard description language and completion of their first proof of concept pipeline with manual driven vehicle in Corla. In P3, they create like ODD specific scenarios for privately owned vehicle, low speed autonomy, and off-road. And for P4, they want to run the full end-to-end simulation pipeline and generate a safety report. Okay, and lastly, we have the safety assurance working group. So safety assurance working group, they focus on developing the safety cases for low-speed autonomy and privately owned vehicle. So for P1, they want to do like tooling for safety baseline scenario. For P2, they want to focus on integration with simulation working group and to execute basic safety report with low-speed autonomy and privately owned vehicle. So for P3, they want to focus on initial safety report circulate for low-speed autonomy and privately owned vehicle. For P4, they are working on safety report, expand to closed-loop testing, and prepare for data collection and real-world testing. So this is the overview of the working groups. Yeah, do you guys have any question before I like go into the details for off-road?
So the
Okay.
working group for the simulation part, most of the thing it seems to be related to Carla. Do you also want to have those things available for AWS in lab soon, or the Carla is the main focus on development for now?
So I think like currently they are trying to like integrate Autoware with Carla, so that's why that's like a one main focus for this working group. And yeah, another focus is to assist the privately owned vehicle low speed autonomy and off-road to help them build a simulation environment and do the vehicle integration.
Okay.
Okay, if there's no question, then I can discuss more about the off-road working group that I'm currently leading. So again, the goal for the off-road working group is that we want to use end-to-end approach to achieve like off-road autonomy for Autoware. And currently we are the target use cases is divided into two categories: the terrestrial vehicle and Mars and Moon vehicle. For terrestrial vehicle, we are focusing on off-road racing and mining vehicles. So why off-road racing? Because that this is kind of like an extension or the next step for racing. So racing and off-road is very challenging. Um, so we want to focus on off-road racing. And for mining vehicles, Autoware gets a lot of interest there are companies working in mining that are waiting to like try out some of the off-road autonomy stack in Autoware. So we also gonna focus on mining vehicles for Moon and Mars vehicles. So currently there is like an ongoing space race. So there's more and more activity in the space in the space. So that's why we are also adding the Mars rover and the lunar touring vehicle. And also these vehicles operates in the unconstructed environment that is aligned with our off-road environment. So the difference between terrestrial and the Mars and Moon vehicle is that we're going to assume for terrestrial vehicle, it can use LiDAR for perception and localization. And for Mars and Moon vehicle, it cannot use LiDAR because of the harsh environment. For the off-road autonomy stack, currently we plan to use a modified version of the AutoSAC foundation model that was developed by the privately owned vehicle working group. So this is a foundation model that was originally designed for highway driving. However, we're gonna modify it. So for the perception pipeline, we plan to train the models using off-road dataset. And for the planning and control stacks, we will have like more changes so that it can accommodate to run on like rugged terrain. So here is a pipeline for the AutoSAC foundation model. I'm not going to go into the detail, but currently there are 6 different network from within AutoSAC. So there are 5 network for perception and 1 for planning. For perception, they have like a network for detecting the lanes, the drivable regions, and also identify uh, road objects and foreground objects, and also perform depth estimation. So currently for the off-road perception stacks, currently we plan to have three network models. One is free space SEC, so it is used to detect the drivable regions. And then we have a object SEC. This is used to identify the foreground objects, such as like structure, vehicle, or vulnerable living. And then lastly, we have a terrain SEC. It is used to identify different types of terrain, for example, like paved road, dirt, grass, or gravel. And then later later planning and control can use this information to like adjust the some of the control parameter like automatically. So we have identified 6 different open data set for off-road. So they are like Rallus 3D, Goose, Offset, CASSED, ORFD, and Yamaha CMU. So they come with like a very wide range of like different classes, and some data set has a lot more data compared to the other. So one of the challenge that we face is that we want to train our model with all of the data sets. So usually, like you will have to uh, write you will have to write like a data parsing script for each individual data sets. So instead, what we did is that we have a data parsing script that uh, uses like the config files to allow us to easily remap the segmentation labels and also redefine some of the file structures from the original data set. So on the right side, you can see this is a config file for one of the data sets. So we can easily just specify what is the pattern for the path for the original data sets. If there's any path that we want to exclude for the data, and what is the destination path, and also how we want to do the map. If there's any like characters in the file name, then we can use this config file to do the mapping. And lastly, we can define how we want to map the label from the original dataset's label to the label that we define. And on the second image, on another config file, we can use this to define like how we want to map from the ID label to the RGB color for visualization. So using this script, we are able to combine all of the 6 data sets and under a unified labeling policy. So as you can see on the first row, we have the source image and also the original label. And then using the script, we are able to remap the label into like 3 separate data sets for the free space sec and object sec and terrain sec. So one for detecting free space, one for detecting foreground objects, and one for detecting different terrain types. So currently we are in the process of training the 3 neural network, and I just heard back from the contributors of our working group that who is in charge of the training, and I heard that we have achieved 80% IOU for the free space segmentation, and we are also currently like testing using some unseen off-road video clips, and also like trying to prepare like a demo video. So we have like we will have result coming out very soon. And currently our next step is to test the perception pipeline in simulation and also in real world vehicle. So next I'm going to talk about some of the simulation work and also like our plan. So for the terrestrial use case in mining vehicles, we plan to use the latest Carla version 0.10.0. So this version comes with a new mining environments and also vehicle for the simulation. So I think this is ideal for simulating the mining scenario. And also this version is based on the latest Unreal Engine 5 with like updated graphic. So for the mining vehicle, we're gonna try Corla 0.10.0. And for the off-road racing, so previously we have integrated the RoboRacer vehicle into Isaac Sim. So in this video, you can see the RoboRacer is like driving on like a step environments. And this vehicle has a suspension system integrated, so the physics looks pretty good. So our goal is that we want to scale this model from 110 to 1/5. We'll use that for the off-road racing. We also develop a configurable racetrack model. So basically, we have a set of parameters that we can tune. So this include like track width, turn angle, turn radius, bank angle, and bank height. So we can like specify these parameters, and then it will generate a racetrack. And our goal is that we want to build a racetrack data set with randomized track features. So later we can use it to train the planning and control stack for racing. And for the simulation for Mars and lunar use case, for the Mars use case, we have built a digital twin environment based on NASA's Perseverance rover's past location. So what we did is that we identified the trajectory of the Perseverance rovers, and we select one with some reference photo, and then we were able to find the terrain data sets of that specific location. So on the right image, you can see the top image is the real photo taken by the Perseverance rover, and the second photo, this is the terrain model that we found, and we are able to locate the exact location from the top image. So you can see there's like a one-to-one match, just a lower resolution on the model. And then we have built this Mars environment. We added custom rock assets, so we can add these rock into the environments, and we also added some detailed terrain textures. And and currently we are working on integrating the Mars rover. So for the lunar environment, we did similar work. So we first identified a few regions that so first we identify what are the candidate landing site for the Artemis mission, and then we select one, and then we were able to find the terrain model of that specific location. So on the lab image, each of the yellow box is a target landing site, and we selected the one that is closest to the lunar south pole. So that's the D Gerlach Rim 2. So on the right side, we found um, the terrain model of that specific location, and you can see that it is overseeing a small, overseeing a crater. So that is at the bottom of this location. So we also added like custom rock assets, and then we make the ground uneven. So currently we are integrating the lunar terrain vehicles into this environment. So that is the current progress for Offroad and Autoware. Do you guys have any questions?
Yeah, yeah, go ahead.
So I'm going to get started so far. Offroad, the specific option from our side. So now we're going to start the commercial.
The audio is not very clear.
Sorry.
I will try because I'm on the phone and I'm outside. Can you hear me now?
Yes, yes.
Yes.
Okay. Just wanted to say that Michał already started the project on this off-road autonomy. So next 2 years, they're going to be working on off-road autonomy with the real car, electric car, normal size, something like Polaris size. So other thing is that we now working on space exploration as well. So we also have the lunar simulator in Unity. So if there are any things that we can share and discuss, it will be perfect. If we are successful, we in next couple of months we're gonna get a couple of million euros for developing analog lunar rover together with the simulator. So I guess it might be helpful for Autoware. And the last thing is about because we are having Autoware for this exploration, and there's concurrently running this Space ROS by Picnic. And I guess it will be good to somehow align with them because they are closely working with NASA and also applying the standards, for example, for ground control and also doing the link for ground control. They also have a simulator, so it might be useful to talk to the guys from Picnic who are leading the Space ROS effort.
Yes, I think that's a great. So there's like a lot of collaboration opportunity here. So yeah, I also worked on a competition, like NASA competition that is based on Space ROS. So I have some knowledge of that. Yeah, so I think like their work is really aligned with our working group. So I think we should definitely collaborate and then help improve the Autoware's off-road stack.
Yeah, Christoph, that's a really
Okay,
good point.
perfect. Very much.
I think
Yeah.
Pojan is being very modest. He actually, along with Alex, participated in the Space Ross.
Won the competition.
Yeah, he won the third place in one competition, and then in the moon
Okay.
competition, he won the
Okay,
second place.
perfect.
So yeah,
Perfect. Congratulations.
I think bridging
Thank
Is there
Space Ross is very important.
is there any option to share these slides? It will be easier for me than to read them because I was on the phone. So if I could go through them, or at least part of this, if you could share, it will be perfect.
Yes, I can
Thank
share
you very
the
much.
slide after.
Thank you very much.
We can share it also and with the meeting minutes and the recording of this presentation. Yes.
Hojan, hi. Sorry,
Hi.
Simon here. I just wondered if you can share a little bit more info on the simulators you're using in the off-road. I know you mentioned Isaac Sim for the racing. Is that the same for the other simulators? And I guess two is how does each what's the suitability of each simulator for this type of control that you and Rahul talked about? And I guess third is there a strategy to converge on a particular simulator in the future, or is it best to have pick different simulators specific to the task? Yeah. Thanks.
So I think like we're gonna use Isaac Sim for most of the use cases. So and also for the lunar and Mars vehicle simulation, we're also planning on using Isaac Sim.
Okay.
The only exception is the mining environment,
Mhm.
because like it's like it is like for Carla, and then I'm not sure if we can directly like pour the environment into Isaac Sim. So that's why we're gonna start with using Carla, but we can also later try to like build our own mining environment in Isaac Sim and then test it over there. Um, so we have like evaluated a number like 5 or 6 simulators, and then I think we're gonna pick Isaac Sim because it has some advantage, like it has very good graphics. So later, if you want to do like a synthetic data generation, then you need a realistic visualization of the environment. So Isaac Sim has that advantage. Um, and it also like uses like physics X, so physics is also pretty good. However, we did experience some issue with like racing. So when a vehicle is traveling at very high speed, sometimes the vehicle can break up in Isaac Sim. So we are still trying to like tune some of the parameters to like avoid this. Yeah.
Okay. Thank you. I understand.
Yes, Christoph, I see you raise your hand.
Yes. Did you have any chance to look at the simulators which are good in physics of the I don't know, like granular media, anything like that? Because I was looking at Chrono, so anyone was having any
Yes, yes.
experience with Chrono? Because most of the simulators are physics based, more or less. They are good in visualization and getting data for computer vision, but they are not really good in simulating what happens with the granular media, for example, which is very common for
Yes,
off-road.
yeah, we also test out Chrono, and then I think that's like the second best simulator, maybe next to Isaac. So that is also an option that we can try Chrono, and I think like there's already some like a Mars rover vehicle simulation based on Chrono, so we can also look into that. So
Thank you very much.
yes.
All right, so this presents a very exciting, direction, and I just wanted to share it with you all, and this is a great way for us to, collaborate on in this direction. Of course, all the other directions are still on, but I'll just,
Rahul?
open up the forum for general discussion now, and Poojan, you can stop sharing the slides and
Yeah,
go ahead. I think Venkat, yeah.
just a quick comment about Chrono. I know that they were working on a ROS port for Chrono. I don't know how successful they were. This was a couple of years ago. It surely would have evolved. And most recently, Dan Negrett got significant funding uh, to further this. So I think they'll be pushing in that direction too. Over.
Excuse me, could you please repeat that?
Sorry, was that addressed to me? My connection was poor for a second.
Yes. I think Pooja and Venkat was just saying that we can see if Chrono was looking into having a ROS2 port, but both Pooja and Alex, they are actively like they are running this, and they have been in contact with the developers. So I think Chrono is an option. There are issues with any kind of simulator, but yeah, that's a good point, Venkat. Yeah, go ahead, Jack. I think you have your hand up.
Yeah, so good to see everybody back. A couple of things. Number one, if you do create some scenarios and then we standardize on the simulator, then everybody can play on the same playground, would be awesome, right? And the second is, would like to bring back the discussion of having an affordable platform. One of the biggest success of the robo races slash F1 Temp is that, hey, here's the parts, put them together. So we could, and I would love to be part of it, where we get some platform that's smaller and more affordable than what Christopher can have. And then we can just get in a backyard or get on some dirt and then start to build things. And then, of course, eventually go to a full-size vehicle, right? So it would be very nice if we can standardize that and give some instructions. And I would love to be a part of it. That's it.
Great. Yeah, that's a great suggestion, Jack, to actually just create some scenarios and then that gets the community started in the playground. I agree. And then having a sim to real with that is something that we are working towards with these scaled vehicle models. It takes some time, but I think we will at least have the uh, digital twin kind of sim scenarios ready pretty soon, and then the vehicle kind of standardization can follow after that. But yeah, that's exactly the direction, but it's good. Like we kind of have to project manage that a little bit to get it out of the door. Yeah.
And a question about the available data sets for the off-road. So I guess you've obviously done a good work in surveying them and selecting data sets and then preparing them. But it does strike me that the amount of data is quite low. So I guess the strategy is to use this realistic simulation to generate a lot more data for training. But is it just generally going to be the case that there's not a lot of real world data available, or do you think Autoware needs to create, or contributors need to publish data sets that are going to be useful in this? And also, there is a lot of on-road data sets which contain roads and structure, which are kind of physically like a off or a kind of highly structured version of an off-road. Is it useful to use a small portion of on-road data to train the kind of segmentation and terrain selection? Yeah, I just want to know a little bit more about the data policy or strategy that you're using in the data off-road working group. Yeah, thanks.
Yeah, so we did a survey on the open off-road data set, and I think in total there are about like 20 to like 20 something K images in total. So I want to say, yeah, I think there is definitely like a limited number compared to like the on-road data set. And also some of the data set is also like it come from like an organization that is sponsored by, let's say, the Chinese government, and they are very strict with some of like the usage of the data set. Like it can only be used for research, and then you need to like sign like you have to like have a sign a signature and agree to that. So um yeah, so there are limited like data set. However, like we also there are a few there is a company, so there's a contributor within the off-road working group. So he works for a company, so he can potentially if agreed by their company, they can provide some more off-road data sets, so that can be pretty useful. And also about potentially adding on-road dataset. I think that can also be useful because um, for the object segmentation, we also look at classes such as like humans or vehicles.
Yeah.
So those also appear in the on-road data set. So we can definitely include some of the on-road data set to train the model.
Thank you. Thank you.
I have so currently I'm collecting some data in like small scale airports. Do you think that means they will qualify for like any of the off-road process that you were working on? It's a little bit different structure than our typical road structures.
I think like I think it might also qualify or be considered for off-road. So yeah, within the off-road data set that we use, there are also some cases like in like more urban or like on-road environments. So I think like for airport that I think I probably need to look at the data myself. But I think that can potentially be considered for off-road.
Okay, I'll probably send an email to you and Rahul after this talk. I'm anyway due from last time to send a little bit of details of the data. But means now we have a vehicle with like 4 camera mounted, which is looking at like 180-degree, and also a lidar and GPS. So if you
Yeah.
need, I can probably collect some data as well. And at VTTI we have some off-road section. I was talking to uh, my facility manager, and he mentioned that there are many areas which has like a long off-road sections that we can probably collect some data. So
Yeah, I think that's a great idea because just having some repeatable, access to some place where we can run repeated experiments, besides just, getting data, I think the data and being able to go back to that environment, of course, it depends on the vehicle dynamics, the vehicle itself, but I think, even just having access to that off-road space would be useful for the Autoware research in general.
okay, yeah, Miss, if you can share a little bit of timeline with me that when I can definitely talk to my facility manager, and if you need, I can probably drive that area a little bit and probably give you a video. That means how it is. Um,
Yeah, that would be great. Yeah, we'll follow up with that. We can just have a chat. Yeah. Go ahead, Christoph.
In the same line, I would wonder how we convince ICRA or IROS organizer to get a couple of tons of sand for the racing of this scaled car. So this might be a challenge.
Yeah, I think that is definitely a logistical challenge, because most of these conferences are in the city, and then every city will have different kind of access, and but I think we'll come to that. I think that is the if we
Yeah,
can.
because it will be cool to have such racing scenarios, but
Yeah.
maybe we just have 2 arenas one in States and one in Europe, and then we do so this was the same that we were thinking for this EV go-kart. So if we could have the standardized platform, and then, for example, one university in Europe and one in US can provide the site, so we can have a digital twin of the site, so we can train, and then, for example, you can send the code or you can come, depends on you. So we can, because I think we have to switch from having this at the conferences to the idea of having like localized arena.
Yeah. And I think we can learn from also, like, all these DARPA guys, they have the facilities, they have done this over
Okay, so on my side, we have 700 square meters. I don't know how many feet it is. And it is covered with spherical tent. So most of the year we can go there, and 300 tons of basalt sand. So we can do some, for example, exploration scenarios.
Yeah, I think, Christoph, it would be really great if in the next month, you and then Abhijit can share a little bit about, hey, look, this is what we are doing here. How can we come closer? Because it just makes sense that we work together, we can do things together, and we can help each other and do things collaboratively. So yeah,
Shall I
totally
prepare
agree.
the presentation for the next meeting?
Yeah, that would be great. And then
Okay,
same thing, Abhijit, we can chat and then we can sort of see. We are still obviously exploring, but I think this is a new exciting area. Yeah, I think Anveshan, you have
because we are really
Yeah, go ahead. Go ahead.
on that and putting our bet on that, so we are happy to
I
follow.
think it's a great direction. Yeah.
In the same way, I mean, what Simon mentioned, so means we can probably explore some of more naturalistic data as well if you think that that will be useful, and because most of our data are geotagged, so we probably know that some of the areas which are not necessarily the typical urban areas, a little bit of rural areas, maybe we can explore that if needed. So please let
Yeah.
me know.
I don't think Simon will ever say no to more and clean data. Right, Simon?
Yes,
Yeah,
exactly.
yeah. So I think definitely, even just the exercise of incorporating it into the Autoware project, that itself will be rewarding on its own. And then,
Yeah,
yeah.
and maybe a longer term view where I guess in the initial training that Pojen has presented, there's need for segmentation labels and specific label information. But I guess longer term as an end-to-end sort of training where perhaps just the raw data and some sort of vehicle motion information, I think maybe is okay for a longer term training strategy, even if the segmentation data isn't there at the moment. So yeah, so I think all these different types of data sources would be very welcome. Yeah.
Great. I think this was a good kickoff to this. I will, Pujan and I will share the notes from the meeting, and we'll have these follow-ups with Abhijit and and Christoph, and close the loop, and of course everyone else to do that, right? And then yeah, it'll be good
Comment,
to
Rahul?
yeah. All right.
One quick comment.
Yes. Go ahead.
Yeah, so even as we're all contemplating data sets and so on, right? I realize that in the on-road space, you're sort of constrained to work with whatever comes out. And here now people are contemplating de novo data sets. It may be useful if we kind of had even sort of a guidelines of what would be good things to have, maybe have multiple tiers of, at the very minimum, the data set should have these are not hard and fast rules, but general requirements that could be tiered, and that way it sort of allows for more interoperability, arguably. So that's just a thought.
Yeah, definitely a good point, Venkat. I think, and as we are doing some kind of rollouts and projects, we will be able to kind of come up with the requirements, especially for these more foundation model approaches. Yeah. Okay, great. Thank you very much. We are at the end of our hour, but we'll keep this conversation going. Thanks for the good input, Jack, and you and Josh and Pojan for waking up so early. And we'll catch up offline then. Thank you so much, everyone. Bye.
See you,
Thank you
everybody.
very much. Okay.
See you.